find the function whose graph is shown below. Here we have a sinusoid. And so we're going to go through and kind of identify our key features here. We have our midline. I like to find the midline first. I think it, for me, it's the kind of the starting point of this process. So our midline up here is at y equals 1. And that's d. And so now we know that d is equal to 1. I have here that my curve goes through the midline right when x equals 0. And when a sinusoid is going through the midline at an easy value to c, then sine is usually going to be the easiest function. So we're going to use a sine on this. I'm just going to write that out. We're working with y equals a times sine of bx minus c plus d. Now, so we have d already. We can get a pretty easily. So I'm kind of viewing this point as my starting point. The amplitude is from the midline up to the maximum. We see that that is just a distance of 1. So a is going to be 1. And then we can get b looking at our period. And here we see that we complete one cycle in 2 pi. And we know that 2 pi over the absolute value of b is the period. Okay, so b is either 1 or negative 1. Now I'm going to put a 1 here, and I haven't talked about the sign yet of, I mean positive or negative, of a and b. For the sine function, we look at our starting point, and if we start by going up, that means a and b both have the same sign. So they could both be positive or both be negative. And it actually really doesn't matter. We just decide what we want. I think making them both positive seems the simplest solution here. And finally for c, we use our phase shift, which is the x-coordinate of our starting point. So our x-coordinate here is 0, and that's c over b for our phase shift. And that tells us that c is 0. And so we can plug those things in here to get our function. Y equals 1 times sine of bx, which is just x, minus c, which is 0, and then plus d, which is 1. So this is simply the sine graph shifted up 1.